Welcome to Healthy Canadians, your space for nuanced conversations and expert insights into the health topics that matter to us all. I'm your host, Beahen, and I'm joined today by Alex Newman, co-host and producer, and today, for those listening in, owner, wearer of a very colorful tropical shirt.
Vibrant, I think is the word you're looking for. And yes, I am a Hawaiian shirt enthusiast as well as being a producer and co-host.
And is there a reason why you wore that shirt today, Alex?
Well, okay, it's a little bit cheesy, and it is part of my regular wardrobe for anyone who's curious. But so as Canadians, we like to get away. We like to go where the sun is in the wintertime, get away from the wind chill and the cold. But some of our critter friends, specifically bugs and insects, are doing the opposite. They're moving north, and they're doing so largely because of climate change. And the problem is they're bringing with them some new and not so friendly diseases.
So today we're talking to senior research scientists at the National Microbiology Lab at the Public Health Agency of Canada, Nick Ogden, and he is interested in climate change and the emergence of infectious diseases. We're also going to talk about specifically ticks and Lyme disease.
Yeah, it's crazy. I mean, like, ticks are so, like, something we all know about Lyme disease. I can't even remember being aware that ticks existed when I was a kid growing up in Canada, right? So, yeah, it's going to be an interesting conversation. But before we jump in, a little bit of housekeeping. So, although Healthy Canadians is produced by Health Canada and the Public Health Agency of Canada, what we discuss won't always reflect the official positions or policies of the Government of Canada. That's okay. These are conversations, not news releases.
Let's talk to Nick about microbial migration. Hi, Nick. Welcome to Healthy Canadians. Thank you for being here.
Thank you for inviting me.
So we don't do this with every guest, but I want to unpack what your title is because I think it's super interesting. So you're the Senior Research Scientist and Director of Public Health Risk Sciences Division, and your research focuses on assessing risk and impacts of climate change on zoonoses and vector-borne diseases. Can you unpack that for us? What are zoonoses and vector-borne diseases?
Okay. Zoonoses are diseases that are transmitted from animals to humans. And most emerging infectious diseases start off or are zoonoses. So COVID-19 was originally a disease of animals that spilled over into humans and then became human-to-human transmissible. Many zoonoses are not human-to-human transmissible. And so we are infected either directly by coming into contact with the animals themselves, like with rabies, or by food and water contaminated by the infections in the animals, or by vectors, which are, in this context, arthropods, so insects and ticks, which take a blood meal from an animal that is infected, and then digest that meal and then feed on a human and transmit the infection that they've acquired.
Yeah, so a couple examples there already that people are really familiar with, and we're going to talk about ticks and Lyme disease in a little bit. But I'd love to know, how did you get into this field of work? Did you get a degree in vet medicine and say, this is it for me, zoonotic diseases and ticks, that's what I'm interested in?
Yeah, I started off as a practicing vet. I was a practicing vet for nearly 10 years in the north of England, a farm animal vet. And we certainly experienced quite a few kind of outbreaks, epidemics that I had to deal with. And one of them really kind of struck home to me, which was that one of my clients, who was a prof at an agricultural college, built this whole new building, which was supposed to be state-of-the-art, that actually had all the right airflow, which would prevent any infections happening, any respiratory infections. So I went to the grand opening of his building, and it was beautiful, computer-controlled kind of vents and things. And then he put some calves in it, and within 2 weeks, they were all coughing with, in other words, our scientific knowledge about how these diseases were transmitted was inadequate. And so that meant, of course, we want to do some more research. And perhaps if we want to do some research and really understand these things, perhaps we ought to understand how diseases are transmitted in wild animals, how in the natural world, and if we can learn from the natural world, then we can probably apply it to livestock and probably also humans. So that led me onto the path of being interested in studying diseases that are being transmitted amongst animals, which ended up with me doing a PhD in the ecology of the bug that causes Lyme disease.
That is a very cool story.
Yeah.
And why is this work so important right now, or how has it changed since those days when you first started to get into it?
Well, I think we have recognized for a long time that, as I mentioned, emerging infectious diseases are pretty much all zoonoses. And even if they may become transmissible human to human at some point, that's their origin. And often they're coming from wildlife, like SARS-1, like COVID, and like many of the kind of influenza viruses, at least in part, those that cause pandemics are coming from wildlife. And we've got a lot of concern at the moment about the H5N1 that has become essentially endemic in Canada now. What is that going to do in the future? So the idea that zoonoses are important for public health has been kind of upfront for a long time. And at the end of the day, the Public Health Agency was founded, at least in part, on trying to address the challenges of emerging infectious diseases. So in other words, emerging zoonoses.
Okay, let's talk about climate change and the impact of infectious diseases and the emergence of infectious diseases.
Well, many diseases, infectious diseases, zoonoses and vector-borne diseases particularly, are in some way sensitive to weather and climate from a range of reasons. Firstly, of course, bacteria and viruses at different climatic conditions may survive better or worse, or may die faster if it's too cold or it's too hot. So changing the climate changes that dynamic of survival of pathogens. Obviously, there are many more complexities to how diseases are maintained and transmitted, either in nature, in human populations, or in livestock populations. And those, but again, there are many impacts of climate on the transmission of those bugs. Since people started to discuss climate change and the possible effect on infectious diseases, the number one kind of group of bugs that people have considered are the vector-borne diseases, those transmitted by insects and ticks, because the survival of insects and ticks and how they reproduce and their abundance is strongly linked and strongly affected by temperature and rainfall.
So does that mean like more ticks? And like if we're thinking about in Canada, does that mean an increase in the amount of ticks and Lyme disease?
Yes, and I'm afraid that we started off with this in about 2003, looking at developing mathematical models to see, well, what could the effect of climate change be? Because at that time, we pretty much didn't have any Lyme disease in Canada, except in one or two locations in southern Ontario, some parts of southern BC, but also occasional infections caused by ticks carried in by migratory birds. So at that time, that was entirely a hypothesis that maybe climate change, which is expected in general to mean that the climate towards the poles becomes warmer and more suitable for bugs, including ticks and mosquitoes, that hadn't previously been able to survive in those areas. So, of course, if we knew at the time that the area of greatest risk in the US from Lyme disease was not too far away across the US border in New York State, the New England, and also the upper Midwest. So we looked at trying to model what would the potential effects of climate change be. Would it mean that the ticks do actually end up coming into Canada in more geographically widespread? And if they do, is it going to be sort of 1 kilometer into Canada, or is it going to be 1,000 kilometers into Canada? And the output of that was that it could be really quite significant. In other words, climate warming, we're just kind of on the edge of the climate suitability in southern Canada. And we also found that there was some areas of southern Canada that were possibly climatologically suitable for the ticks. And then we went out to have a look with field study, with dragging flags, dragging blankets to try and find the ticks that are seeking a host. And we did find early signs, so we did get some sites at that time. But subsequently, those ticks have really moved in and have spread really quite dramatically into southern Ontario, southern Quebec, southern Manitoba, and the Maritimes.
So basically, in 2003, you had a pretty good hunch about what was about to happen, and you were right.
Well, there was a hypothesis, and yes, it turned out to be right. And actually, the climatic limits for the ticks that we estimated turned out to be pretty accurate as well.
Wow.
Yeah.
Let's talk about when you just said the dragging of. Did you say dragging of a flag? Yeah. I would love to know more about that. Like, what is the field research for your work, and are you doing it?
I used to do it.
Okay.
Now I have members of my team who do
it. Walk us through it a little bit.
However, I must fully confess that I've been fascinated by tick-borne disease since I started studying it. And ticks tend to live in nice places. So they're in nice woods and parks. When I go to Africa, they're there in the Serengeti. They're in the sort of the all these parks in Europe and Northern Europe. So they're a nice species, and it's a nice bunch of diseases to study.
Yeah. So you don't mind doing the field work?
No,
either.
not at all.
Okay.
But the ticks are they don't fly. They hide away in the duff layer, in the surface layer of woodlands, where they're protected from cold in the winter and heat and desiccation in the summer. And when conditions are right, they kind of come out and climb up onto twigs and pieces of grass and pieces of foliage, and sit there waiting for a host to go by. So they have this sort of ambush strategy. So they're just sitting there waiting for somebody to go by, or an animal to go by. But and because they're really interested in feeding on animal hosts, on deer, on mice, on rodents, on birds and squirrels and so on. But they're not very choosy. And so if a person goes by, they'll jump onto a person. And they'll also, if you drag a flannel along the ground, they will also can be fooled into thinking that that's something to an animal as well. It's moving.
Yeah.
And so they jump on it, and then you turn it over and you can see the ticks and collect them.
Just like a regular flannel blanket?
Yeah.
Okay, so tell me about it. You drag it through, you bring it back to a lab,
or you're
in the field?
You turn it over and you collect the ticks off it,
okay.
And you use usually a standard distance, or at least a standard time that you've dragged for, and then you count the number of ticks that you collect. You take them off, and then you start again, and so you cover a sort of standard distance with a standard protocol, so that we're doing a repeatable way of looking at different habitats and trying to understand. Do you find ticks in this place because the habitat's good, or in this place because the habitat and the climate is good?
Okay.
So, and with the amount of study that we've done, and we have done an enormous amount in collaboration with our provincial colleagues, so we've got a very good handle on where the ticks are occurring in Canada. Clearly, there's more to know, but we have visited really thousands of sites.
So pretty safe to say you're not too squeamish about bugs then?
No.
No, or at least not ticks.
No, not at all. They're fascinating. They're fascinating. And some of those the ticks that occur in Africa are really quite beautiful.
Tell me more.
Lovely iridescent colours.
Ooh, hard to be scared of those kind.
Except they are big. Actually, they are big.
I like how big.
Yeah, sort of.
Oh, that's big.
Yeah.
Oh wow, like an inch.
Well, at least you can see them. The part of the scary part about a tick is like how small it is and unidentifiable.
Unknown
you
thing.
know.
It strikes me like how effective this surveillance has been though too, because like we're used to it now, which is kind of amazing that like ticks and Lyme disease have just become part of the public awareness in such a short amount of time when you think about it. Like I don't ever remember being concerned about ticks when I was a kid in the 80s and 90s, or things like West Nile or anything like those were never a concern. So it's like when you take a step back, it's like although we're all kind of used to hearing about this now, like this has really happened at an accelerated pace, right? Like
and I've seen it in kind of in my backyard. I live in southern Quebec, and we have a park there, which is a very nice kind of park with cross country skiing trails in the winter and mountain biking trails in the summer, and it's very visited. And when we first set out to examine whether those models are actually telling us, is it right? It was one of the sites that we visited. 2007, 2008, no ticks. In 2010, one of my team went back again and found one tick. And then subsequently, the ticks have set up home, the proportion of ticks infected, the transmission cycles of the bug that causes Lyme disease have set up. And I think we've had 3 postgraduate students doing PhDs based on studying that woodland. It's gone from nothing at all to really being quite evident risk for the public.
Well, and we don't want to scare people either, right? We want people to go outside. We want people to enjoy green spaces and parks, right? So maybe we could talk a little bit about prevention and how to enjoy the outdoors knowing there might be ticks around.
In the park near where I live, we started off with no Lyme disease risk, and now we have significant Lyme disease risk. But going to that park is good for your health, right? Getting out, doing the exercise, getting fresh air. So it's an inherently healthy activity. And the important thing is to manage that risk. And I know a great deal about Lyme disease and ticks, and I go to that park at least once a week. So if you stay on trails, pretty much, particularly if they're made trails, your risk is pretty low of actually getting a tick at all.
That's good to know.
We actually did a study where we looked to see if we could actually collect questing ticks that are looking for a meal on the trails, and then for certain distances away. And actually, I don't think we found a tick on the trails, but the further you go into the woods, in other words, the further you go off the trail, the more likely you are to find a tick. So stay on the trails, if you can, and with an increasingly hot Canada, it's not easy to ask to wear long trousers and long sleeve shirts, because and to tuck your trousers into your socks. The reason for that is that the ticks have climbed up onto herbage on the woodland floor, looking for and waiting there for a host. And if they cannot get up your trouser leg, in other words, they have to go over the top and walk up your trousers in order to, you're much more likely to see them.
Okay.
And to be aware that they are there. So if you can, do that. Some say that the only people who are ever going to be seen out with their trousers tucked into their socks are entomologists and epidemiologists, which may be true. But the other thing is to wear insect repellent. The DEET or Acaridin insect repellents, which do repel the ticks as well. The other thing is when you get home, what do? Firstly, you take your clothes off. If you're not going to wash them straight away, it's feasible that ticks have climbed onto your garments, and they've not buried their heads into you and started to feed yet, but they're there and can do so at a later date. If you put those in your clothes in the dryer on high for about 10 minutes, it'll kill any of those ticks. Then have a shower or a bath, and then look for any ticks that might have attached to you. Ticks are not like mosquitoes that fly along, bite quickly, and disappear. They need to feed for days in order to take a blood meal. And what they do is they kind of climb up your leg, search for somewhere suitable to feed, and then they dig a little hole in your skin and stick their mouth parts in and kind of cement themselves in for the long haul, and then start feeding on you. Now, you don't know about that because
thank God.
They have got loads of pharmaceuticals in their saliva.
Oh yeah,
which prevent you from knowing that the ticks have put their heads in, and then they're modulating the inflammation that produces to manipulate you so that they get the best blood meal. So
tricky.
They are tricky, fascinating, and actually the saliva of ticks is being explored as possible sources of pharmaceuticals.
Cool.
Because anti-inflammatories and so on. In fact, there is an antihistamine that has been developed, which was developed from an antihistamine produced by ticks.
Wow.
So
that's interesting.
Anyway, the look for ticks that are attached to you, and if you see a tick attached, then pull them off. There are sort of instructions of how to do this on our website and many of the provincial.
There's little tools that you see sometimes too, right?
The best thing is a fine pair of tweezers, so that you can get the tweezers down right close to the skin, and so it pulls out the head of the tick. Sometimes you can leave the head of the tick in, but it's not a disaster. I wouldn't go kind of digging away trying to get it out. And I've removed ticks and left the head in on a number of occasions, and they fall out in the end. So, and the reason for doing that is not only because we don't want the ticks attached, is because that if you pull the ticks off, then it will very likely prevent the transmission of the bacterium that causes Borrelia burgdorferi, because the Borrelia burgdorferi, the bacterium that causes Lyme disease. The bacterium is in the gut of the tick when it's looking for a host, and once it starts feeding, those bacteria have to multiply and then spread around the body to the salivary glands to be delivered into you. And that takes sort of 24, 48 hours for that to happen.
Okay.
So if you're on the case and pull the ticks off, and it's really been shown to be quite effective.
Okay.
Yeah, that's really good to know. I didn't know that.
That's good to know after that extremely graphic.
We always bring the good news
Everyone's
afterwards.
giggling in the studio because I could see people getting a little bit
There's
squeamish
some
about it,
cringes happening.
but not Nick.
No.
So safe to say you're not squeamish about getting bitten. How many are you, like a beekeeper where
I'm not.
You're like immune to
No,
stings?
actually, one thing is that I'm not very likable as far as a tick's concerned. For some reason,
do tell.
They don't attach easily to me.
Really?
I don't know why. No.
thinking about the public awareness, that too, like these are all pretty practical things that anybody can do to prevent it, right? So I think like is part of the challenge just because it's happened so quick and people aren't used to it? Because I mean, people in other climates have lived with ticks, presumably. Like, how important is public awareness as well?
Public awareness is really important, and I think that the perception of risk is important. In other words, as well as the knowledge of what to do with that risk. I think it's important that that people who are really at risk are made aware of the presence of the risk and how to manage it, and that is going to be our main tool against Lyme disease. The other issue, though, is perhaps there are parts of Canada where there is very little in the way of Lyme disease risk. And people knowing that as well is probably a good thing. Is if you were doing tick checks every time you went out for a year and found that you didn't find any ticks, and then you go, well, I'm going to stop doing that. And then next year is the year that suddenly your part of Canada has become suitable for the ticks because of climate change, then you may have stopped just at the time when you should be starting.
So when we talk about people most at risk, we're mostly talking about areas where there are more ticks or more Lyme disease present?
I think it's geographic areas, geographic regions of Canada. Obviously, the ticks need to live in woodlands. The woodlands provide those refuges from the far zero temperatures in winter and protection against heat and desiccation in the summer. But they also provide all of the animal hosts. The ticks are obligate parasites. They cannot survive without having animal hosts to feed on. So the regions that are suitable for the ticks are by and large those with a suitable climate. But within those regions, there are locations, there are types of habitats where the ticks occur and types of habitats where they don't.
And so how would someone find out if they're in a region where there are more ticks? Like, I know for me, I find out because I have a dog and my vet tells me. Every year I go back for an annual checkup for my dog, and then she tells me, like, is it high, is it low, what are we seeing in the region where I live? Where would someone find out that information?
Well, pretty much all of the provinces provide information on their websites as to where risk is believed to occur, and more local information. And we compile that on our website. There's now sort of kind of a zoomable map where you can see, which is updated as regularly as we can.
And so we talked about sort of like the individual risk of ticks and Lyme. What is like kind of like a big picture, like a macro risk in Canada? Like, what does this mean for us, for the healthcare system, for people, for the environment? Can you talk about that a bit?
Well, I think it's an inevitability that we've got relatively, apart from protecting ourselves from tick bites and managing the risk, and maybe there's a vaccine in the kind of pipeline for the future, but I don't think it's for a very near future. It is a reality. We can't, though, really control the spread of the ticks. That's an entirely wildlife associated phenomenon. So we can't actually control the ticks without doing some interventions that would likely be very unpopular to altering the habitats in which the ticks are occurring. So that leaves us with those options for control and prevention that we have. I think that, as I've mentioned, the spread of the ticks and the bugs that they carry into Canada was a hypothesis and has been for until the last kind of decade, when it's suddenly become, this is a reality. And to see that we are heading towards the kind of situation that we see in the US, and particularly in the northern US, because the northeastern US states and the upper Midwest states are those where the incidence is highest.
That's interesting too. And I mean, not to ask you to look into the future, although it seems that you're pretty good at it. Beyond Lyme disease and ticks, are there things now that we're kind of picking up on, or other sort of tick-borne or vector-borne diseases that are thinking could be risks in the future or could be emerging?
Yeah, sure. And we're looking at, I guess, a number of particularly vector-borne disease risks. There is another tick that is heading north from the US, which is called the Lone Star tick, which transmits a number of bugs that the black-legged tick doesn't, but it also induces allergies to red meat for some reason. It has a sugar in its saliva called alpha-gal, and if you get you feed a lot of ticks, then you can become allergic to that. But that's also in red meat, and so people can end up with allergies. That tick's kind of moving quite slowly. Fortunately, it doesn't seem to be dispersed very well by migratory birds. I don't really know why, but migratory birds are very good at spreading the black-legged tick that transmits Lyme disease. But for some reason, this tick it doesn't seem to be carried very easily by migratory birds. So that's something we're keeping an eye on. More immediately is that we see that the Asian tiger mosquito has set up home in the warmest parts of southern Ontario, and maybe there are other parts of Canada, particularly southern British Columbia and southern Quebec, which may also be climatically suitable, but we haven't found the mosquito yet. But this is I guess rather unexpected, that it is a mosquito that transmits those kind of nasty diseases we hear about affecting people in the tropics, like Zika, dengue and chikungunya. And so we're now in a situation where we've got this mosquito is now set up home, and we may have periods in the summer now where it's, for at least for a short period of time, we could have transmission of these bugs, dengue and Zika and so on, just for short periods. But nonetheless, it could be what would happen is that somebody returns from travel with dengue or chikungunya, and they have the viruses in their blood, and then the mosquito bites them, and then goes and bites somebody who's not traveled. And so that becomes a diagnostic challenge for doctors who find somebody with that situation when the person has not traveled. Dengue is not going to be high on their list.
Yeah.
So we're exploring this with a view to identifying where and when that kind of risk can occur, so that medical practitioners can be aware, public health can be aware, and the idea that we may have short-lived outbreaks of these kind of bugs is not science fiction, because that has happened in Europe.
We filmed an episode yesterday with a food safety scientist, and we asked her, she knows so much about food risks, and does it impact her enjoyment of food or preparation of food? Okay, does she think about it too much? I'm going to ask you a similar question, although I already feel like I know the answer. Do you know so much about ticks and Lyme disease that it impacts you in any way? Like your risk perception?
It doesn't impact. It does not impact me, I guess, other than for myself, because I feel I'm pretty good at managing my own risk, but obviously there's never say never that I'm not going to get any one of these bugs. But I'm more I am concerned. I recognise my concern for Canadians who are not, for whom this is new, and for who may become sick with these bugs, and they're not pleasant bugs.
Right.
So we have a job to do.
Right. And is that what motivates you in your work?
Yeah, absolutely. I mean, that's very important for what we do. But they're intrinsically fascinating things. So.
Sure, yeah.
Thank you so much, Nick. It has been a pleasure to talk to you. We're going to link all of the resources in the show notes and all on our website, so people can have some more information about prevention and tick awareness. It's been great chatting with you.
Thank you.
Thank you so much. Thanks for tuning into Healthy Canadians. If you're watching on YouTube, click the like button and subscribe to stay up to date on all future episodes. Find us wherever you get your podcasts and leave us a review if you like what you heard. For more information on health topics that matter to you, visit canada.ca/health.